Hey guys, it's Villanueva here. So I'm going to show you guys real quick and make you a short video on what we're doing today. And just a refresher for those of you that needed the extra help with the electron configuration. So here's our periodic table. Here is our electron configuration table. And we're going to do an element called arsenic, which is this guy right here. Okay. So we're going to do a couple of things today. I'm going to show you a couple of different ways to write the electron configuration, but the process to do the electron configuration is still exactly the same. Okay, so just remember that we have to get to arsenic. We have to get there step by step, row by row. Okay, so we have to start at hydrogen in the first energy level. Okay, and then we have to make our way down to arsenic. Remember that every step through an element is one electron. So in the first period, we have two steps. Step one, step two. Second period, through the S block, we have one step, two steps. Okay, one step, two steps. From there, if we were to keep walking, we'd end up in the P block. So to get through P block, it would be 1, 2, 3 steps. 1, 2, 3 steps. 4, 5, 6. Okay, so now we've walked through the second period. Now we're in the third period or third energy level through the S block, 2 steps. 1, 2. Then we go into the P block, which is 1, 2, 3. 1, 2, 3. 4, 5, 6. Remember that you have to add all the positive spin electrons first until you have all the subshells filled up, and then you go back and you add the negative spin electrons. Just a reminder, a positive spin electron is an arrow pointing up equals positive spin. Okay, and an arrow pointing down equals your negative spin electron. Okay, so that's what I'm talking about when I say positive and negative spin. All right, so now we're in the fourth energy level. Okay, here you're going to take the first 2 steps through the S block. 1 step, 2 step. Okay, 1 step, 2 steps. From here, you're walking straight into the D block. Remember that the D block is always 1 energy level lower than the period that it's in. So from the 4S, you go to the 3D. So I'm going to add all my positive spin electrons. 5, which represents these elements. 5, and then go back and add all my negative spin electrons until we fill up D block orbital all the way. 7, 8, 9, 10. All right. Now from here, we go from the 3D, we go to the 4P. Okay, that's exactly where we're at. Now, I want you to take notice of this because to get to arsenic, it's only 1 step, 2 steps, 3 steps. So it's going to be 1 step, 2 step, 3 steps. Notice that even though it's only 3 steps, there's no other negative spin electrons because this electron right here represents arsenic. It's this guy. Okay, so we're done. This is the electron configuration. All right. Now, here's what I'm going to show you guys today. Here's what we're doing today. When you're doing an electron configuration, you don't need to draw all these boxes, do all the arrows. This is for you guys to understand the concept. Now I'm going to show you a shorter way of doing this. Okay. Once you get the electron configuration, you can write it in a shorter way. So look, we have the 1s orbital. Okay, and the 1s orbital has 1 electron, 2, so it has 2 electrons total. From the 1s, we go to the 2s. So the 2s orbital has 2 electrons. From here, we go to the 2p. The 2p has 6 electrons. Then we go to the 3s, 3s2, 3p6, 4s2, 3d10, because remember you had to go to the D element first, right? 4p3. Okay, this is the shorter way of doing the electron configuration. Now, all I did was take the symbol that's here, the 1s, and then as an exponent wrote down the number of electrons, 1s, 2 electrons. The 2s also has 2 electrons. 1, 2. Okay, then we get to the 2p6. Well, 2p is this guy right here. Okay, and in this guy we have 2, 4, 6 electrons. So that's where this number comes from. And so basically what it is, instead of you guys having to go through and draw the arrows and do all this other stuff, you can write your electron configuration just like this. Okay, now here's the other trick. Here's the other trick. If I was to go to this electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 3p6 is this guy right here. Okay, it's argon. So this whole configuration, here to here, can be written or replaced by the element argon. Okay, so instead of writing all of that, all I have to do is replace it with the symbol for argon. Then I write down the configuration that's left over. 4s2, 3d10, 4p3. And this equals that. It's the same thing. Basically what we're doing is, if you were to start at hydrogen and go through the 1s2, 2s2, 2p6, 3s2, 3s2, 3p1, 2, 3, 4, 5, 6, you'd end up at argon. So instead of writing all that configuration, you can actually replace all this configuration with argon, and then just write the configuration of the row that you're in. We call this noble gas configuration. Erase this here. Okay, this is noble gas configuration. So I'm going to just label that. And it's just a shorter way of doing electron configuration. Okay, now there's a couple of ways to do it. And basically here's the rule. Okay, whatever element you're doing, all you have to do is go up one energy level and then go all the way to the right of that energy level, okay, and figure out what's the noble gas at the end. What's the noble gas at the end? So for example, let's say I wanted to do rubidium, right? This guy right here. Well, to do rubidium, I would go up one energy level, go all the way to the right, and figure out that the noble gas there is krypton. So to do the noble gas configuration of rubidium, it would just be krypton. And then that is in the, let's see, 1, 2, 3, 4, 5, S1. So this configuration would be exactly the same as if I was to go through and do 1s2, 2s2, 2p6, and go all the way through. Now, if I ask you to draw the full configuration, then yeah, you got to do all this, right? But if I ask you to give me noble gas configuration, it would be this one. This is noble gas, right? And if I ask you to give me the shorthand configuration, it would be this one. So that's it, guys. I wanted to make you this short video because what I want you to do is I want you to take the two elements that we did on Thursday, that I assigned on Wednesday and Thursday, and then I want you guys to give me the shorthand configuration, and I want you to give me the noble gas configuration. All right. Hopefully this gives you guys a little bit more help. If you want me to make a video of something more specific, please let me know.